Hi, welcome to this video in which we cover past paper questions on vectors for CSEC AdMath. The first question is from the first AdMath paper, May-June 2012. Given that vector OA is equal to A, vector OB is equal to B, and vector AP is equal to half of vector OA, where A is 2, 1 and B is 3, 2, write BP in terms of A and B, and find the magnitude of vector BP. Now, we know to find BP, we're going to need other vectors. So vector BP is also equal to B plus some unknown value plus the same value P. What do we know that we can fill in these blanks with? Well, from the question, nothing explicitly, but you should note that we're given OA, OB, and AP. Here, I'm going to use BO and OP. While we don't know OP, we know vectors that can give us OP. So BP is equal to BO plus OP. But OP is also O plus some unknown value plus the same value P. We're now able to complete this because we can use OA and AP. We know that BO is the negative of OB and OB is equal to B. Therefore, the negative of B is equal to negative B plus OA, which is equal to A, plus AP, which is equal to half of OA. A plus half of A is the same as 1.5A, or 3 over 2A. So we know that BP is equal to negative B plus 3 over 2A, or 3 over 2A minus B. Next, we're asked to find the magnitude of BP. We know that BP is equal to negative B plus 3 over 2A, and we know that A is 2, 1 and B is 3, 2. Therefore, vector BP is equal to negative 3, 2 plus 3 over 2 times 2, 1, since those are the values of B and A. We know that we're going to multiply this negative 1 by 3 and 2, so BP is equal to negative 3, negative 2, plus 3 times 2 over 2 gives us 3, and 3 over 2 times 1 gives us 3 over 2. When we add negative 3 and 3, we get 0, and when we add negative 2 and 3 over 2, we get negative a half. Therefore, vector BP is equal to 0, negative a half, but we're asked to find the magnitude of BP. The magnitude of BP is going to be equal to the square root of its x component squared plus its y component squared. Its x component squared is 0 squared, and its y component squared is negative a half squared. This gives us the square root of a quarter, which is equal to a half. Remember to put your units. The next question is from 2013. The position vectors of 2 points P and Q relative to a fixed origin O are 10I minus 8j and lambda I plus 10j respectively, where lambda is a constant. Find the value of lambda such that the vector OP and vector OQ are perpendicular. So we should recall this formula. Which states that the dot product of two vectors A and B is equal to the magnitude of vector A times the magnitude of vector B times cos theta, where theta is the angle between A and B. Now we're asked to find the value of lambda such that these vectors are perpendicular. If they're perpendicular, that means the angle between them is 90 degrees. Therefore, the dot product is equal to A dot B times the magnitude of A times the magnitude of B times cos 90. We know, however, that cos 90 is 0. So this means that A dot B is equal to 0, since it would be the magnitude of A times the magnitude of B times 0. The dot product is going to be equal to the product of the I components, so 10 times lambda, plus the product of the j components, negative 8 times 10, which should give us 0. Therefore, 10 lambda minus 80 is equal to 0. 10 lambda is equal to 80. Lambda is equal to 8. The position vectors of A and B with respect to a fixed origin O are given by vector OA is equal to negative 2i plus 5j, and vector OB is equal to 3i minus 7j respectively. Find the unit vector in the direction of AB. Now we know that AB is equal to AO plus OB. AO is going to be negative 1 times vector OA, which would give us 2i minus 5j, plus OB 3i minus 7j. This will give us 5i minus 12j. Now this is vector AB, not the unit vector in the direction of AB. To calculate the unit vector in the direction of AB, we need to calculate the magnitude. This is going to be equal to the square root of 5 squared plus negative 12 squared, which gives us the square root of 169, which is 13. And therefore, the unit vector in the direction of AB is going to be 1 over 13 times the vector. Because the unit vector in the direction is always going to be 1 over the magnitude of the vector times the vector. Alternatively, you could write this as 5 over 13i minus 12 over 13j. From 2017, given that vector p is equal to 2i plus 3j and vector q is equal to I plus 5j, determine the scalar product of the two vectors p and q, and determine the angle between the two vectors. Now, the scalar product is going to be equal to the product of the I components plus the product of the j component. That's going to be 2 times 1 plus 3 times 5. 2 plus 15 gives us 17. The angle between the two vectors we're going to calculate using the dot product formula. Now, the dot product p dot q is also equal to the magnitude of p times the magnitude of q times cos theta. Transposing, we get that cos theta is equal to the dot product over the product of the magnitudes. The dot product was calculated to be 17, and the magnitude of p is going to be the square root of 2 squared plus 3 squared, the magnitude of q, the square root of 1 squared plus 5 squared. This gives cos theta to be 17 over root 13 times root 26. Therefore, theta is equal to cos inverse of this value which to one decimal place will give us 22.4 degrees.